Okay, so next question, which of the following statements about Fermi level is or are correct? Okay, so now about Fermi level, very important concept as per your exam point of view. So before going to statement, let's first discuss the concept and then we will come back to the statement so that we will make the answers, right? So let's come to our whiteboard here and now we will start the discussion of Fermi level. So first, you should know the definition of Fermi level. Okay, and what is the definition? It is the probability, you can say, it is the probability of occupancy of electron. Probability of occupancy of electron, that is 50%. Okay, means what? It is the average energy level where the probability of electrons presence. Okay, where the probability of electron presence is how much? 50%. Okay, now we should understand the Fermi level is at middle for intrinsic semiconductor. Okay, so this is the suppose intrinsic semiconductor. What is the meaning of intrinsic? Means electron density in conduction band is equal to hole density in valence band. Means number of electrons in conduction band is equals to hole number of holes in the valence band. Okay, so this is the basic structure of your energy band diagram. So this is your EC, that is conduction band. This is EV, that is valence band, and this is your middle. Okay, exactly middle of conduction and valence band, which we call intrinsic energy level. Okay, now for intrinsic semiconductor, your Fermi energy level, which we denoted by EF, is at middle of the semiconductor, right? Now suppose I am doing doping. So let's add some donor impurities. And why we perform doping? Because for some applications we want that, right? So whenever I will add donor impurities, means what? This is N type. Okay, I am adding the electrons here. So electron density, because of donor impurities, electron density, okay, is much greater than now as compared to the hole in the valence band. Result, because of which what will happen, that in the energy band diagram, the Fermi level, okay, the layer which was at middle, this layer is now shifted towards conduction band. Because why? Because electron density is more. Okay, number of electrons are more now, so that's why the Fermi level is shifted towards conduction band. So one key point you got from here, that whenever N type semiconductor is there, okay, this becomes now N type because of donor impurities. So in N type semiconductor, or sometime in N type extrinsic semiconductor, whenever we add impurities, it is called extrinsic semiconductor. Okay, now based on impurities, whether they are donor or acceptor, we call N type or P type. Okay, so in N type semiconductor, the Fermi level is below conduction band. Very important key point and MCQ you may get from this question. Okay, so now again the scenario is what? Electron density is much greater than the hole density in valence band. Okay, so all these things are happening at room temperature, normal temperature. I am not increasing temperature yet. Okay, we are discussing at room temperature only. Now let's say if I will add acceptor impurities, that is P type impurities, I can say P type. Okay, in this intrinsic, then what will happen? Now the holes, okay, as I am adding acceptor impurities, so holes are much greater than, holes density much greater than the electron density in conduction band. Okay, much greater than electron density in conduction band. So now the conduction is because of holes only. Okay, and resulting, because of which what will happen now? This is your again conduction band, this is your valence band, and this is exactly middle. Okay, so now your EF move towards valence band, that is Fermi level, okay, is moving towards valence band. So now what will happen whenever I will add acceptor impurities? First thing, conduction because of holes. Okay, holes are more than electrons. In case of donor impurities, the conduction is because of electrons, because electron density is greater than hole density. Okay, and one more key point we got, that Fermi level is above valence band or above valence energy level. Okay, and this we denoted by EA, and here this we denoted by ED, donor energy level, and here it is acceptor energy, right? So from this directly you will get MCQ. So just remember always this thing, right? Now let's rough this. And now let's say, now we understood, see, ki what, ki whenever at n type, the Fermi level is on top and below the conduction band, and at p type the Fermi level is above the valence band. Okay, above the valence band. Let's say this is ED and this is your EA. Okay, now this is everything at happening at room temperature. Let's increase the temperature now. So whenever I will increase the temperature, what will happen? Electron hole pair will get generated because bonds are break. So electron hole pair gets generated. Okay, and as electron hole pair get generated, all the electrons and holes which are there, okay, start to get equal. Means the densities of electron and hole will get equal. So as I increase the temperature, suppose 0, 10, 20, 100, 200, 300, what will happen? The Fermi level, okay, goes down like this. And it will come to directly middle, which is your intrinsic level. Like this, okay? So Fermi level, whenever I will increase the temperature, the Fermi level in N type, okay, come down to the middle, and the Fermi level in P type come up like this. Say I am increasing temperature 0, 10, 100, 200, 300, right? So this is happening. So now at very high temperature, what happens? Your EF, which was at above the middle in the conduction band, or which was below the conduction in valence band, comes to the center now. Okay, and again we got here intrinsic semiconductor. Okay, this is your valence band EC, and this is your valence band, this is valence, and this is your conduction band. Okay, so again EF is equals to EI. So I hope you got the concept, and now let's rough this, and again we can go back to our question. Okay, so I hope now you will able to answer. So first I want pause the video and try to answer based on our discussion, and then play to get the answers. Okay. First statement, when the temperature of N-type semiconductor increases, the Fermi level tends move towards the center of the energy gap, okay, which is the band gap. So yes, this is the statement correct, as we already studied that the Fermi level was on top, okay, but whenever temperature increases, it comes to the middle, okay. When the temperature of p-type semiconductor increases, the Fermi level tends to move into the valence band, okay. So it is going into the valence band? No, it is come again to the middle of the band gap, okay. So that's why this statement is wrong. And the position of the Fermi level does not change with temperature. No, it will change with the temperature. Yes, okay. So what two important key points we studied or we learned, that position of Fermi level EF is proportional to temperature and doping. Yes, okay, we added impurities. First we add donor impurities, then we have acceptor impurities, and what we observe, the Fermi level is changing as per the concentration, right? So this is very important key point, which you will write in your short notes and you will revise before your exam. Okay, so the position of Fermi level does not change. No, it changes. So that's why they ask us correct. So only one statement, that is only S1 is correct. Okay, so this is the answer.